Here, also known as as.ws on Instagram. And today I'm going to show you how I made this thing. I'm super excited. I really enjoy this project, and I've spent way too many hours customizing it. And yeah, just like there's so many variations, and I'm really hoping that you guys can explore it for me as well. A couple few other things is thank you for all the love on the Instagram. Um, I really wanted to start off 2025 super strong, and I think making a tutorial is the best way to do that. So yeah, this is my first tutorial as well. So hopefully you guys enjoy. Okay, so before we actually get started with this tutorial, I would love to talk a little bit about the math that goes behind it, because since I am making a lot of my pieces with actual math concepts, um, I also kind of want to give you guys some context on how I'm thinking about solving these problems. If you don't want to, if you're not mathematically inclined, don't worry about it. You don't need to know what's going on to actually make this piece. But I hope you can stay and try to learn, because why not, right? So if you can notice, my piece is a bunch of cubes that are going in straight horizontal and vertical lines. This concept is called Manhattan distances, and it's the idea that if you have 2 points, well, there are many ways to get the direction on how to get from P1 to P2. One of the most simplest ways is doing the nice subtraction of two coordinates being P2 minus P1. And this will give you a uh, direction vector. And what that direction vector does is it essentially points my P1 towards P2. And then using any sort of way that you find necessary, maybe linear interpolation, getting the magnitude, you basically can use this direction vector to teach the computer how to draw a perfectly straight line from P1 to P2 with like no fail, right? And so if you have this calculation right here, no matter where P1 or P2 moves, you'll always ensure that they are perfectly connected. Now this is what we would call Euclidean distances, where we're allowed to use um, diagonal lines. But Manhattan distances sort of asks the question, well, imagine if we were in Manhattan or like in a grid city where we can't really take diagonals. Well, then how can we get from P1 to P2 such that we can only use horizontal and vertical lines? Well, the solution to that is pretty straightforward. All we really need to do is we just add a new point. So now we have P1, and then our P2 is now here, and then we have P3. And so there, if we do all of the subtractions, we get our horizontal and vertical lines. So by using noise, we might get a scatter of random points in 2D or 3D space that looks like this, where I have P1, P2, say P3, P4, P5, and P6. Well, if I wanted to get, let's say, the Euclidean distances, i.e. we're allowed to use diagonals, then all we have to do is do P6 minus P5, P5 minus P4, so on and so forth, to get all of the direction vectors that would allow me to interpolate between all of these points, which is great. But it's not exactly what I want, right? Because all of these are diagonals. So I was trying to think of a way to incorporate these intermediate points into my system of noise so that I would be able to get only horizontal and diagonal lines. And so what I came to the realization was, if I have a random starting point as P1, say 0, 0, Well, my next point, P2, will have one of the coordinates fixed, right? So it's either going to be, let's say 0, 2, right? That could be my P2. Or it could be something such as P2 being over here, where it's 2, 0. But basically, the new point can only go horizontal or vertically. And so one of the coordinate locations is always going to be dependent on the point previous. So say that my P2 is now this one, right? Now my P3 has to be going down this way. And so this P3 could be something like 2, -3. And then if I wanted P4, well, P4 could go maybe like here. And so this one would be the coordinate. What would that be? That'd be like, I don't know, 1, -3, right? And I can continue this chain, and I'll do the exact same thing as before, where I subtract like P4 minus P3, so on and so forth. And what I'll end up getting are Manhattan distances instead of um, Euclidean distances. To start, just get rid of this network, and we're going to bring in a constant chop. Within this constant chop, I'm going to have two channels, one called nodes, and then another one called interpolation. For nodes, I'm just going to set that to 10, and for interpolation, I'll set that to 1 for now. Then we're going to get a null, and we're going to turn on that viewer active. I'm also going to copy and paste a text stat. And you can get one just from this pink file, and it's just down here. But this text stat will have some very important code that we're going to be using to create our Manhattan distances. So just keep that on. I'll provide that in the description below the YouTube channel. So yeah, now that we have all of our important parameters, we're gonna go into a noise top. And we're gonna use this noise top to basically sample all of our random values. So I'm gonna put this into random, and then we're gonna put amplitude to 1 or offset to 1. We're gonna change the resolution to be 1. And then we're going to grab our nodes, and then we're going to put our resolution Y to be the node size. Then I'm going to turn on nearest pixels, and then I'm going to change this to 32-bit float mono. Something that I'll do from time to time is I'll put on this viewer active and press D, and it will just give me all of the pixel values of my texture. It's pretty useful for me to see what values I'm actually working with, and all you have to do is do this, and it just goes, turns on and turns off. The next thing I'll get is a limit top, and I'll put that to loop, and then I will get a null. And then with that null, I'm gonna chain this to a top to top, and I'm gonna get rid of all of the channels except for our red, and I'm gonna call this position sampler. From there, we're going to get the full image, and then we're gonna get a null, and we're gonna call this null position sampler. So now we're gonna have 10 points for our 10 nodes, but then I'm gonna go back into my noise, and I'm going to add 2. And these, basically this first value and these last 2 values will be the location of our first point, because it's the only point that's gonna have 3 random numbers. All of the other points will be dependent on the point before, so the rest will just go to the other nodes. One thing to note is that this text file is very dependent on how you name things. So if you really want to make sure that your position sampler null is named correctly, otherwise things will break. The next thing that we're going to get is a constant top, and we're going to do the exact same thing. We're going to first set our color to be 0. We're going to set the resolution X to be 1. We're going to drag our nodes to the resolution Y, nearest pixels, and then pixel format, 32-bit float RGBA. The next thing that we want is a rectangle. And a rectangle top, I'm going to name this to be a mask. And make sure that the 1 is still there. But what we're going to do now is we're going to change our pixels to, we're going to change our size to be in pixels. We're going to change this to both be 1 by 1. We are going to change our center to also be in pixels. We're going to change our justify horizontal to left and our justify vertical to be bottom. Next thing is turn off anti-alias. And then from our input, from our comment tab, we're going to do the exact same thing. Resolution X to be 1 and nodes to be, or Y to be 10. And then nearest pixels, and then 32-bit float mono. Now I'm going to get a point transform. And this one will go into a null. I'm going to call this null node position. And I'm going to add another null afterwards. And this one will be node position viewer. For this one, I'm going to turn on the viewer active. And then I'm going to hover my cursor over the box and I'm going to press V. And yeah, if you zoom out a little bit, you should be able to see a very small point. And that's basically all of our pixels in 3D space. Oh, one thing to do is turn off adaptive homing. And yeah, we should be good. So the first thing that we want to do is we want to use our op.position sampler, and we're just going to put that into our translate X. For our TY and TZ, I'm going to also do the same. But for these ones, instead of it being me.digits, I'm going to do -1 and -2. And basically what me.digit does is it takes the point or the number that the node has and it samples that number. And so for me, this is basically doing 1 - 1, which gives us the first position of our position sampler, which is right here. So one of the things though, right, is that you see when we do our point transform, our entire texture has changed. If I zoom out a bit, you can see, oh, maybe you can't see. That's okay. But what is important is to make sure that, well, what we really want, right, is only the first pixel to be moved. Because otherwise, every single time we use a point transform, the entire texture is going to move and we're not going to get different points. It's just going to be one same point. So that's where this mask comes in. The point transform is a tool to move points in a texture. And the second input is basically a weight. So 0 being, it goes from, I think, 0 to, or like negative to positive, but 0 means that it doesn't move at all, and 1 means that it's just moving the amount that you specified. So when I put this into my point transform, this mask, you'll see that the only point that moves is the bottom one, because that's where my mask is. Another thing that you want to do is in your mask, go back to your rectangle, and we're going to call me.digits again, -1. And this will give us the position of our pixel. When we copy it again, Now mask 2 is in position 2. Position 1, position 2. And this will help us basically help us move every single point individually without it being too tedious. So now what I want to do next is I'm going to add another point transform. And with this point transform, I'm going to, again, copy my op.position sampler and put that into my TX. Now for the other two, like I said before, every single point after the first point will be dependent on the point before it. So this line of code right here basically references the Y location of our previous point. We're going to do the same thing and reference the Z location of our previous point as well. So now we have a random point in 3D space, but the only thing that's random about it is our X channel. Now I'm going to press C and I'm going to color this red. Now we're going to do the same thing with our point transform, but this time I'm going to drag this into my green channel, my TY. And then for my TX, I'm going to put that into that one. And my TZ, I'm going to put it into TZ. I'm going to color this green. And then we're going to do it one more time for our blue channel. For our blue channel, it's going to take on input. We're going to take this position sampler and we're going to bring that into the blue channel. And then the other two are just going to take the TX and our TY. Now we're going to color this blue. And this is our pattern. Now all we need to do is we need to ensure that this pattern stays consistent. So we're going to need to create, since we have 10 nodes right here, we're going to need to create 7 more occurrences of this pattern of point transforms. So starting with the red one, goes into here. Then it goes into our green one, and our blue one, and then one more time, a red one. And I know this is not the most elegant solution in terms of creating a texture, but I don't care. I think I really wish that I could find a better solution to how to approach this, but I was pretty happy with the final result anyways, so I'm not too concerned. It's a bit tedious, but it gets the job done. So I'm happy. So now we want to do the exact same thing with the mask. Every single mask should go into the respective point transform. So mask 2 goes into point transform 2. Mask 3 goes into point transform 3, so on and so forth. And because we use me.digits, we don't need to actually change anything about our mask. All we really need to do is just copy and paste, which is super, super nice. And there we go. So now we have a bunch of random points. And if we were to look at our point location, you'll see a bunch of tiny, tiny points that are just kind of in a grid-like system. So now what I'm going to do is I'm going to take my node position, I'm going to select it, and I'm going to bring it over here. Next up, what I'm going to get is a transform. And I'm going to change the translate to be in pixels. And I'm going to create the system that helps me create the direction vectors. What I want to do, right, is I want to do P10 minus P9 P9 minus P8, P8 minus P7. And by doing that, I'll be able to get all of my direction vectors that will help me interpolate my paths. So what I can do in here is I'm just going to do -1, and that translate it down by 1. So now we have every single, if we grab this node and we grab a subtract, now what we have is we have every single node being subtracted by its previous node. Now we want to tile this to be mirror because the first node has nothing to subtract from. So it's just going to subtract itself. Now in the subtraction node or top, I'm going to alpha mask the channel. And then I'm going to grab a crop. And I'm going to put this interpolation into my crop right. And then I'm going to grab a ramp. And then I'm going to go back to my select. Grab an add. There. And then a null. And I'm going to turn on the 3D viewer for this null right here. And now I'm going to increase my interpolation. So I like to bring it up to, let's just do 1000. And you'll see what we get is nothing like Manhattan distances. The reason why is because we need to change our pixel viewer smoothness. So go back to the select, right click to grab all of these nodes. And then in our interpolation, we want to put nearest pixels and nearest pixels. And look at that. Now we have a bunch of straight lines. Super cute. One thing to note is, well, I just want to talk about what's going on right here. So this crop right here is essentially increasing our texture by 1000 times. So what's happening is we're getting 1000 points, and this ramp is using those 1000 points to draw lines in the directions of the direction vectors. Now, we use this add because this add gives us a starting point for each node. So if I remove this add, I'm basically removing my starting positions. And what I end up getting is a bunch of vertical and horizontal lines that start from 0, 0. They're in the right direction, but they're not in the right starting point. So that's why we need to add this select, because this is where our nodes start. And it basically tells us, tells the computer where to begin and stop, not just stop. Like so. And yeah, I'm going to call this Manhattan distances, or just Manhattan distance. And you can see if we change the noise seed, we get a bunch of different pathways. So now that we have this, let's create our render setup where we can instance this distance. So I'm going to go into a box saw. I'm going to go into a transform. I'm going to change the uniform scale to be 0.05. I'm going to add a null. And then we're going to chain a geometry. Make sure that wire is there. And also, we're going to grab a camera. And we're going to get a material, a constant material. We're going to put that into our material parameter. And then we're going to get a camera. No, a render. And with that render, I'm gonna change the resolution to be 1080 by 1920 because social media. Next, we're gonna do a transform top, and we can comp that over background, and then we can get a null. Let's call that background, and then I'm gonna turn on the display. And now I'm gonna split my panels. I'm gonna drag this all the way over here. I'm going to go into my top viewer. So, and then I'm going to right click. And then I'm gonna turn off my backdrop tops. So now that we have our render set up, I'm going to put my Manhattan distance into my translate OP. And I'm just gonna go RGB to get my Manhattan paths all down. And you can turn on the viewer active to your camera to move around your angle to find something that looks good. I'm gonna say, no, this is fine. Or I don't know. Yeah, this is good. And the next thing that I want to add is an SSAO, which just gives you a bit of shading. Just copy all of my settings. Oh, and also if you're ever doing a tutorial and you are like confused on what I changed or what someone has changed, and you're like copying like an actual file, you can press this little circle button up here and you'll get all of the things that they've changed. So just add that into there. You'll see that we have like a bit of shading. Very subtle, but it makes a difference, I think. If it lags you, don't worry, you don't need it, but I just think it's a pretty fun addition to any geometry scene. Okay, so the next thing that we want to do is let's get some movement. So I like to create movement by using my scale, or like the illusion of movement. So I'm gonna grab my Manhattan distance top with a select, and I'm gonna add a ramp, and I'm gonna set my ramp to be resolution only. Then I'm gonna add a null, and I'm gonna call this Manhattan scale. And I'm gonna bring that into my scale OP. And we're gonna do the exact same thing, RGB. And yeah, so you see now we have these little points. And what we can do with that is we can do abs time dot seconds in our phase. And there we go, we have some movement. Look at them go. Okay. So a few things. The first thing is there's an interpolate notches. Usually I like to keep that as ease in, ease out. It allows for a bit more smoothness when it comes to these movement things. The next thing that I want to do is you can click on the ramp viewer or the color tab or whatever it is to create new notches. I'm gonna create 2 new notches and put my my value of 1 in between that, and I'm gonna put 1 more notch on the very end. On the end notches, I'm going to set the value to 0.05, and we're gonna put that one as 0.05 as well. We're gonna turn these ones to 0.05 as well. And we're going to do that as well. Ooh, yeah, that's good. And then I'm gonna bring these up very, very close. And then we're gonna change this to be, let's say 2. Oh, why does it look like that? Oh, okay, my bad. I had this bypass for some reason. Okay, so now we have our lines. Look at that. So what I've done here is basically with my ramp, I can control my scale by just by controlling this value here. So when my ramp is at 0.05, it's basically just telling my node, my SOP, to shrink down by that amount. or I guess like grow by that amount. It basically shrinks a lot more. What I can do for this one right here, I can change this to 2. I can also change it to like 5, right? It just increases it by multiplying the entire size. I think 2 is fine. Now, let's add some color. I'm going to select my Manhattan scale, and I'm going to add a noise. And in my noise, I'm going to change my noise output to be input times noise. And then I'm going to add a null and call that Manhattan color. So from there, what I want to do is I want to turn off monochrome. And now what we can do is we can go into our second instancing tab, and we can just do R, G, and V. And now that's super flashy, which we don't want. So we want to turn the scale for our TX to be 0. And there we go. Now we can play with our period. Lower period gives us randomer values. We can also increase our amplitude for more vibrant colors. I like to put my period to be like 0.3. And then usually that gives like a nice little sweet spot of like 2 variations of color. One thing that you'll notice is because my background here is black, my wires have also disappeared. What you can do is just change the background color to be like something white. Yeah, like that. And yeah, another thing that you could do is you could get rid of this background by doing, actually, I'm not gonna get into that just yet. Let's make this a bit nicer with some more post-processing. So what I want to do next is just add a bloom. And again, I honestly don't really know what I'm doing in terms of post-processing usually. So I would say just experiment and try your best. Because I wish I could teach you guys what I'm doing, but I just move things until they look good. And I mean like, yeah, that's pretty good to me. I don't know. You can like adjust the bloom radius. You can adjust the amplitude of the noise. Yeah, I think that's fine. You can change the offset as well. And yeah, I'm going to color this noise. I'm gonna color this purple so I can remember that I can like modify it to make things look different. And that's basically it for this the system. You can change our noise like this to create more different pathways. So one more thing that I forgot to add while editing was you can also add noise to honestly any part of this patch, but I would say like this one's pretty fun, and this one, like the scale and distance. If I add a noise to this one, then it sort of starts like glitching out, I guess, like whoa, and then I can add a noise onto my Manhattan distance as well, and really increase the size of that. See what happens. But yeah, okay, so how to make this bouncy. Let's go into our chops, and I'm just gonna add a keyboard in, and I'm going to add a count, and then I'm going to add a null. And from there, I'm gonna chain that to my seed. So now every single time I press 1, I get a new wait. Next, what I want to do is I want to go to my my select right here, and I'm just gonna bring this select into Chopland. And bringing this into Chopland is, you want to be careful with that sometimes, because if your top texture has a lot of pixels, it's gonna get really laggy. But luckily, we only have 10, and so it's gonna be pretty easy to work with and not be too laggy. So we're gonna select output as single channel set, And then we're going to go into crop, and we're going to crop full image. This gives us all of the channels as one single chop. And then we're going to add a lag. We're going to add a lag per sample so that we lag the entire chop. And then I'm going to add a overshoot of 0.2. The next thing that I'm going to do, well, now if I press 1, you'll notice that these kind of glide to my next position. So we're going to bring this back into tops. We're going to go into RGBA. And then we're going to, well, we want this to be the same as this, right? So we're going to flip this, and more specifically, we're gonna flop it. The next thing that we want to do is we don't want to replace all of these individually. So I'm gonna right click this node notch right here, and this gives me a little like an extension. So I'm gonna press tab and I'm gonna add a null right there, and then I can just replace it like so. And if you did it right, nothing should have changed. But now when I press 1, it bounces a bit. Look at that. You can obviously increase this if you want. You can do like something way crazy. And now you're way bouncy. I like 0.3, I think. You can also increase the lag at which it sort of glides into the next position. But yeah, so that's how you make it bouncy. The next thing that I want to go through is, so usually, well, 10 nodes is not that much. So how can we increase this? Well, there's a few things that we need to do. So number one is we just need to increase this nodes setting. And let's say we do like 12, or let's say we want to do 15. So now that it's 15, you'll notice that we have this Manhattan distance that's kind of just like, well, it's not straight anymore, right? And the reason why is because we're missing all of the point transforms that need to happen to make sure that it is, I guess, like perfectly horizontal or perfectly vertical. So what we need to do is we need to continue this pattern. So again, we just do this slowly, but you'll notice that, oh, and then this max needs to be at 11 right here. We'll do another one, and we just do this, this, and this. And unfortunately, this is a bit tedious. I have created a replicator comp that I will give out to my Patreons. But the good thing is that once you sort of have the nodes placed down, you can essentially just go in between how many that you want. And yeah, I'll just go for 13. But yeah, and what I mean by that is, well, now that I have 13, I can go back down to like maybe 6. And then I can go up to 15, or sorry, 13. Perfectly fine. Other points of interest, I would say, is playing around with this ramp. You have 4 types of ramps, and all of them kind of give really cool effects. Another one that you can do is you can decrease the period. And I always really like this one. When you decrease the period, you get more, like, I guess, instances of scale. But yeah. Another thing that you can do is you could also create a wireframe. And a wireframe is just going to, all you really need to do is go into your constant, turn on topology wireframe, and then create that to be, whoa, that's way too big. I don't know, 7. And with that, you can create your own, you can create a new like system. So let's say that this right here, we'll say this is instead wireframe, right? And we can also create a wireframe, nope, a wireframe color. And with those, we can just replace the 2 right here. And yeah, it's up to you, really. Yeah. Anyways, I think that's good. That's probably, yeah. I hope you liked my tutorial. If you did, like, comment, subscribe, the whole shebang. Um, if you want, follow me on Instagram, and I would really appreciate it if you supported my Patreon. People who support my Patreon will get well, the replicator comp that is basically allows you to go from like 10 nodes to 100 nodes instantly. And also, any Patreon supporters will also get the exact project file and any variations that I think are kind of interesting that they could experiment with. If you do create something really cool out of this tutorial, please let me know. Tag me on Instagram or like give me like DM me or something, whatever it is, because I really, like I said before, I love how much I can play around with this patch, or like how I can play around with any patch. It's just that I can't spend all day on a single patch. So I'm passing it off to you guys. I hope you guys create really cool things. I'm really excited to see what you guys come up with. But yeah, I'll see you guys in the next tutorial. Thanks for watching.